Hi, this is your Math 2 homework help for Unit 11, Lesson 2, Multiplying and Factoring. In today's lesson, they probably talked about a couple different ways to do these problems here. One method of solving might have been the box method, and another method they may have shown you perhaps the distributive method to solve these problems. Okay, if they didn't do those, I'm not sure what else they may have done. These are the two that I'm going to work with today, and I'll solve different ones and different methods just to give you a feel for how that works. Okay, so let's start off first of all, number one, for the distributive method. The way we do this is we're going to take the 3w and we're going to multiply that to the first w. If you think back to Unit 10, when we had exponents with the same base, when I multiplied exponents with the same base, I add the exponents together. So in this case, 3w to the first times w to the first, because of the same base, and I'm multiplying, I'm going to actually add those exponents together, so I end up with 3w squared for the first part. Now, because I'm not done yet, I'm distributing, I also have to take this 3w and multiply it to the 2. Now, the 2 has nothing to do with the w, just like over here, the 3 had nothing to do with that w. So, but it does connect with the 3. So 3 times 2 is 6, so we're going to say it's a positive, plus 6, and the w just stays like so. Okay? So that's a little bit of distributive method there for one way you can do that. Let's say I took this one and wanted to use the box method for it. That would look like this. I would take the one term, I'm going to draw a little box here for you. So here's my box. And put it up into two parts. I have z plus 5, and over here I have 2z. And the box method would say, well, 2z times a z gives you 2z squared. And then over here, 2z times 5, 2 times 5 is 10, and I still have a z. And that's going to be a positive. So my answer, if I was to rewrite that, would be 2z squared plus 10z. Okay? And you could do that distribute as well. If I look at it this way, 2z times z is 2z squared, and 2 times 5 is z, 10z. So it really becomes like what's comfortable for you to do, what do you like doing. I tend at this point, I just do the distributive method almost every time, and not the box, because it saves me a little bit of a step because I can see how that lines up there. All right. It's also more of a chance for me to make an error in transferring over when I do box method. I might forget to put a plus sign or a squared in my solution, but it's okay. All right. So let's try another box method here real quick while we're at it. I have 3m squared, and this term is 4 plus m. So 3 times 4 is 12, and I keep the m squared. And 3m squared times m to the first is now 3m to the 2 plus 1 is 3. So I end up with 12m squared plus 3m to the third. Your teacher may want you to write that, in standard form. If that's the case, you would change the order of those to put 3m to the third plus 12m squared. Not sure what they've asked you to do or not. Let's do another one down here. Let's look at number 8. Number 8 says, I'm going to look at this one and say, let's distribute. So first I'll do negative 4h times negative h to the third. A negative times a negative is a positive. So 4 times 1 is 4. And my h, I have 1 plus 3 is 4. Next one, negative 4 times a negative 8. A negative times a negative is a positive. 4 times 8 is 32. And 1, 2, 3 h's. And then over here, a negative times a positive is a negative. 4 times 2 is 8. And I have h to the first, so I have 2 h's on number 8. Okay. Let me pop over here to quick number 6, I guess, once I'm doing it. Show you another one like that. So negative 3a times a negative 3a. 3 times 3 is 9, but it's a positive times a negative, so it's negative. I have a to the first, a to the second. Combine those. 1 plus 2 is 3. Look at the next term. 3 times a positive 2 is positive 6. I have 2 a's. And 3 times a negative 7 is a negative 21 with just 1 a in that one there. Okay, so that's the idea for that first section. The second section is find the greatest common factor of the terms of each polynomial, which means you're basically going to be going backwards. If you look at number 1, for example, number 1, we already had that it was 3w squared plus 6w. That's great. And what it's asking you is, what can you take out of each term to put on the outside of the parentheses, which in this case we started with, well, there's a 3 there and there's a 3 inside of that 6, so I could take a 3 out. And they both have a w, so I could definitely take a w out. It's not even asking at this point for what would be left in the parentheses. It just wants to know what's the part that you would take out. So when I look at number 10, I can see that I have 16 and I have a whole number. It's good to know that 16 times 2 is going to be 32, which means there's a 16 in here and there's actually 2 16s in there. So I would take out the 16, and that actually is my answer. That's my greatest common factor, is just 16. There's no variable they have in common, so I would leave it as that, just 16. If you were to be asked to do the full problem and really to factor this whole thing out and leave it as a polynomial, you would actually say 16, and this would be times q, because that's what's left, plus what's left here. We left a 16 behind. 2 times 16 gives me 32. So that's where you're headed eventually, but right now this section just wants to know what's the greatest common factor. So when I look at number 11, I know that I see a 4 here, and I know 4 also goes into 24, 4 times 6, so I can definitely take a 4 from both terms. I see this has a t to the third and a t there, so I can definitely at least take one t out of both terms, and that becomes my greatest common factor. If I look at number 13, I see there's x and x and x. I don't see any whole numbers or leading coefficients that are in common there besides 1. And so the only thing I can actually take out of this is one of the x's. That's all I could take out. Number 14, I see 5, 25. I know 5 is in common for all those terms. I only have d's in those two, so I can't take a d out of everything. Only thing I could take out would be a 5. And finally, let's look at number 16. I have 7, 21, 14, which tells me I could take out 7 and a 7 and a 7. Those are all multiples of 7 times 2, 7 times 3. I could definitely take a 7 out. They all have g's. I have g to the fourth, third, and second, which means there are at least 2 g's in each term. So I can take out 7g squared for number 16. When we get to the the third part here, it actually now wants us to complete the process and factor it out. So let's do a few of these together. I notice that 3 and 9 those have something in common. 3 goes into 9 3 times. I know I can take a 3 out. So I ask myself, okay, if I take a 3 out, what number times 3 gets me to 9? 3 times 3 is 9. Now I need to have a t there because I still need a 3t. What number times 3 gives me a negative 3? It's going to be a negative 1. And that's how I factor that one out. So you have to think through each part of it. For number 20, I might recognize I look at 12 and 28. Well, 12 times 2 is 24. So 12 is not the greatest common factor. So I'm going to kind of go down from 12. I can look at maybe like 6. 6 goes in there, but 6 does not go in 28. So let's try 4. 4 goes into 12. Yep, 4 times 3. And 4 goes into 28, 4 times 7. So I can certainly take a 4 out of the whole thing. There's only a j in the first term, so I can't take a j out. So that's as far as I can go with the greatest common factor. And now, because I wrote it up above what the factors are going to be, I know that what's left over here is 4 times 3, and keep my j to the third, plus 4 times 7 for the 28 right there. Okay? Looking at number 21. Same idea. I decide what goes into both of those. If you know your math facts here, I might look and say 72, 63. Oh, I know. 9 times 8 is 72. And let's see. 9 times 7 is 63. I also notice that they both have x's in them, so I could certainly take out at least one x. So I'm going to take out a 9 and an x for my greatest common factor, 9x, and then I have to ask myself, how do I get from 9x to 72x squared? Well, what's left? An 8 and one more x are left there. This is a minus. I need to get a negative sign here. I already have the x, good there, and what's left is 9x times negative 7 will get me negative 63x. For number 22, I'm going to look and see there's no k, there's only k in the first two, so I'm only going to be able to take out perhaps a whole number. And I can look and say, well, I have a 6 and 12 and 9. 3 becomes a common factor. 12 is 3 times 4, 9 is 3 times 3, and 6 is 3 times 2. So I'm going to go ahead and take the 3 out and then see what do I have remaining. I have 4k to the third minus 3k squared plus 2. So you can see by writing out my factors here of these numbers, it just tells me right away what I'm going to have left for my solution once I take out the greatest common factor. Let's look at this one as well. I can look here and say that I have 12, 16, 20, and I recognize right away, for me at least, that this is 4 times 3, this is 4 times 4, this is 4 times 5. So I know I can take a 4 out of the whole thing, out of every term. I also see that I have an n squared here, and I have an n to the third, n to the fourth. So that means I can take out 2 n's from everything. Okay, so let's go ahead and put them back together, put it back together on this part. I have, what's left over is 3, and if I got rid of 2 n's, 4 minus 2 is 2. And this term here, I have a 4 left over. I take away 2 n's, so I'm left with 3 minus 2 is 1. And over here, if I take out 2 n's, all I'm left with is the 5. And that's as far as I can go for number 25. Let's look at one more, number 27. I like it because I have a 7 in all of these. This is 7 times 1, 7 times 3, and 7 times 7. So I know I can factor out a 7 of every term. I also have a q with every term, so I can at least factor out 1 q from each term. So when I look at what's remaining here, I know I have a 1 plus a 3 minus a 7. I'm not done yet. I did a little different order here. I have to go back and put the q's in. I took 1 q out of everything, so 1 less than 5 is 4. 1 less than 3 is 2. 1 less than 1 is nothing, so there's nothing to write there. And that's what I have for number 27. Okay, let's flip it over to the back side and see what we have on this next one here. It wants you to go ahead and continue doing the same idea, simplify it, and then write it in standard form. So let's do a couple of these. I'm going to go ahead and do number 29, 33, 35, 36, and 37. All right, so we're going to go ahead and multiply out and write it in standard form. So I'm going to distribute here. Negative 3 times 2 is negative 6. For the m's, same base, so I add up. 1 plus 2 is 3. Negative 3 times negative 5 is a positive 15. And for my m's, it's 1 plus 1 for 2. Negative 3 times a positive 10 is a negative 30. And I just have the 1 m there. The terms go 3, 2, 1, so it is already in standard form, so I leave it just like that. This next one here, I have a couple to distribute in this problem. So I do 5y times y, which becomes 5y squared. 5y times 2 is going to be 5 times 2 is 10y. And then I have negative y times y is a negative y squared. And the negative y times negative 3 is a positive, negative times negative is positive, 3y. I need to combine my terms, so here's a y squared and a negative y squared. And here's a regular old y and a regular old y. So the y squareds combine to make 5 minus 1, 4y squared. And 10 plus 3 is a 13y. And I'm already in standard form because y drops down from 2 to 1 to nothing. So I'm in standard form already. Number 35, it wants us to factor each polynomial. Number 35, I recognize that 13 times 3 is 39. Okay? But I also have a C here, a C there, a D there, a D there. So there's portions of this that I could take out. So I'm going to go ahead and take out a 13. I recognize that there's at least one C in each of these, so I can take out one C. And there are 3 D's there and 2 D's there, which means there are at least 2 D's in each term as well. For the first term, because I took out a 13 and a C and 2 of the D's, so 3 minus 2 is 1, I'm left with just 1 D in that first term. Over here, I know I'm left with a positive 3, because 13 times 3 is 39, and I only took out one of those C's, so I have one C left, but I did use both the D's, so I leave it just like that. Number 36, I also recognize again that 5 times 5 is 25, so I can take a 5 out of everything. They each have at least one X, and they each have at least 2 Y's. So now when I see what's left, I took out the 5 already. I have still, between there and there, I still have 2 X's left, and I still have 2 Y's left. I'm going to keep my minus sign here, my negative, and I'm going to bring down that 5 for this term. And I already took out the X, and I already took out the Y squared, so I can leave it just like that. Let's do one final one, number 37. 28 and 42. I can look and think to myself, well, how's this going to work out? Well, what am I going to take out here? Well, 14 times 2 is 28. Also, 14 times 3 is 42. So I'm going to go ahead and take out a 14 and then look at my letters. I have 5 M's, 4 M's, which means I can take out at least 4 of them. I only have an N in that term, so I can't take out an N. I'm left then with 3 M to the first power, or just M, and the N plus 2, and I took out the 4 M's already, so all I have is the 2. So I have 14 M to the 4th times the sum of 3mn plus 2. The rest are very similar to that, so hope you have the idea and that helps you out a little bit. Thanks. Have a great day.